Okay, so let's start. So this particular course named as RF and Microwave Engineering, the course code is ECC 17102. So this is the first lecture. Basically, we are going to talk about the course curriculum, assessments, and the differences, correct? And what sort of challenges are there? We'll try to discuss. So my name is Raghavendra Kumar Chaudhary, correct? You can see the email ID over here, raghavendra@iitsm.in, and the second one is ecc17102@gmail.com. Correct. So this is the phone number. I'm reachable over this phone. Now let us begin. So this is the motivation. So before having this course, we're supposed to have some motivation that why one should go for this course. Correct. Now you can see there are number of applications are there, and particularly if I start from the antenna and radar, then communication, then we can see domestic application, then EMI, EMC, electromagnetic interference, electromagnetic compatibility. Then after we have a transmission line, one of the important thing in our daily lives too. Then after we have radio astronomy, imaging, and all the things. So particularly if you see this particular box transmission line, so we are mainly in daily life, we are interacting with coax, waveguide, and USB. And if you talk about the communication particularly, so basically nowadays we are using mobile, Wi-Fi, satellite, and all that things. So in daily life we are interacting different frequencies, correct? And without these frequencies we cannot find our life or working properly. Particularly antenna is one of the most important part actually of our life. And if you see in your mobile, you have a different antennas carrying. Fine. So like if you talk about the domestic application, so we know about the RFID, TDR, automobiles. So RFID you might be seen in, at the malls actually. So when you are going out or going in, so that particular two stands kind of things are scanning to you that you are not carrying some goods without billing outside to the that market, correct? And another is TDR, time domain reflectometer. So basically BSNL people and the telecom industry people are using to track where the cable cut is there, where the problem is there, like that. And finally you can see Tesla and all the things they are working over the driverless cars, correct? So here the things very much going to use. So these are the different frequencies going to use to run the car, like to find the accuracy, correct, where the crowd is more, fine, and to detect the nearby objects, correct. So these are the some of the things and some of the frequencies we will be uh, interacting in our daily life. Okay. Now, what are the course objectives? So the course objectives are to uh, particularly for this RF and microwave, as the name suggests, so we supposed to interact with the higher frequency. So the high frequency analysis method for the different type of transmission line, microwave devices, and design techniques we are going to see in this course. Then after we'll see some of the passive and active device commonly utilized in microwave system are analyzed and studied. Then after design procedures will be presented along with the method to evaluate the device performance. And finally, we'll understand the theoretical principle underlying microwave device and networks. So if we talk about the course plan, so I divided the course plan in the four units. Mainly unit 1 and unit 2 are very important units actually. And basically unit 1 we are going to learn with the transmission lines and all the sort of mathematics basics which will be helping you to understand um, different concept of active and passive devices, correct? And definitely at the system level you can also analyze the systems properly if you know these sort of parameters, correct? So we'll be talking about in details the transmission line, input impedance, different load conditions, bounce diagram, voltage current on the transmission line, standing waves, transient analysis, quarter wave transformer matching, and the matching with the help of the Smith chart, double step or single step. So these sort of the things we will be doing. Then after we'll see the networks, and mainly here we'll see learn about the S parameters, scattering matrix. These are the very important thing, because to analyze any sort of passive and active device in the microwave, we need to understand the S parameters. So by having the S parameter, you can predict so many things. We'll see that what we can do with the S parameters in detail. And we'll also see the filter design method by insertion mode. This is one of the basic method I'll try to cover in this course. Unit number 3 and 4 concerned with the passive components and active components. Particularly passive components like terminator, attenuator, phase shifter, direction coupler, hybrid junction, and all sort of passive devices. We'll try to learn its mechanism, what is the working principle, and what is the mass behind these passive components. We'll see all sort of these things. As well as we'll see also the active component, that how it generates the microwaves, correct, with the help of klystron, correct, and we will also see TWT, magnetron, gun diode, impact diode. So this is these four big area. These four big area will try to see in this course, and we'll try to make a background so that other application could be well understood. Okay. Now, what will the learning outcome? So upon having the successful completion of this course, you will be broad understanding of the transmission line at the high frequency. Then you will have the idea of the Smith chart to find the unknown impedances of the transmission line, and for the different circuits, particularly matching. And then we'll also see the S parameter to solve the inside of the passive and active component. And definitely you will be coming across the working principle of different active and passive component. So these are the textbooks actually which I'm going to use to cover the course. So textbook actually you can use R.E. Collins Foundation for Microwave Engineering. This is second edition, written on this things McGraw-Hill 1992. And these are the references book you can we will be using for this course, and particularly book number 2, which is Field and Wave Electromagnetic, written by David K. Chang. Second edition we are going to use to learn the transmission line. And then after S parameter and all sort of things, network related thing, we'll use the David Ozar Microwave Engineering, which is third edition, Wiley 2005. And apart from this, we'll also see technical notes and application notes of the various devices. Now, coming about the assessment part, so I believe you might be getting the updates from the Dean Academic side, and basically this time we are going to have the quiz and assignment of 52%. Its component is 50% and 48% for the end semester exam. So particularly this 52% we are going to split as the quizzes, 4 quizzes between 40% to 52%, and assignment 12 to 0%. So this is the point where we can discuss that what percentage we can keep. So later on we'll discuss this now. But the thing is, there are 4 quizzes actually we need to perform within these durations actually. Like quiz number 1 we have to perform 24 to 29 August. Quiz number 2 we have to perform between 7 to 12 September, like that. Okay, so this is the thing. And particularly about the end semester, when you are returning back to the campus, the plan is like that. When you come back to the campus, and we will be having the end semester examination. Okay, these are the lecture schedule. I believe you know this thing. So we have a Monday and Friday. So this is 11 a.m. to 11:50 a.m. Then Wednesday 12 p.m. to 12:50. Lab timings are Thursday and Tuesday 2 to 3:50 p.m. Now let us begin these things, because we have all sort of information about the courses. So it is important that we should touch, at least in the first class, what is the idea, what the things we'll see, and what are the challenges we are going to face in this course, and what solution we will be getting actually. So the thing is, like, here you can see there is a low frequency and high frequency, correct? So mainly in your BTech first year, second year, and this things, third year, you have seen the low frequency applications. Like if I correctly recall the things, so your basic electronics lab, where you use KVL, KCL and mesh analysis, and finally you develop a circuit over the breadboard by using the lumped component. These lumped components basically are inductor, capacitor, and all sort of things, correct? The idea is there that you are not worrying about the phase and all the things. That is why we are measuring the frequency and current without any hesitation that what is the phase and other things. So mainly the dealing with the current and voltage. Now the problem with the high frequency is that you cannot measure the current and voltage, because in that case what is happening, that your lambda, okay, the wavelength is the comparable with your device size, correct? Or maybe sometimes this is very small as compared to your device. So there is a high chance that there are the number of maxima and minimas are there with the high frequencies, correct? So it is difficult to measure voltage and current. That is why we are dealing with the power at higher frequencies. Now let us discuss this RF and microwave frequency spectrum. So particularly, I would say here that 300 kilohertz to 3 gigahertz, this range we are saying is RF, and beyond this we have a microwave. Okay, so this is one of our terminology used by the RF engineer across the world, correct? However, in general, you can say these are the microwave frequency are working. Particularly microwave, like if you say see the name, so this is a very small wavelength actually, and particularly you will also see a term is called the millimeter wave also. So these are some sort of IEEE bands actually, correct? IEEE bands here. So starting from the VHF, UHF, L band, S band, like that. These are the frequency ranges here, correct? So here, particularly in transmission line, we'll try to cover up to the X band, and in a lab also we'll try to cover experiment in a X band. Some of the simulation will carry out in this also, because right now the thing is accessibility of the hardware is really difficult. So this time we'll see some of the simulations also, how we can carry out on the system, correct? Now, let us see. This is the IEEE wireless services with the frequency band. These are some different services actually, and if you see your mobile, you will be able to match this thing, that all the things you are using in a daily life. So these frequencies are touching your life daily actually. Okay, and particularly if you see the GPS, so many applications. Without GPS nowadays, you forget about pizza and burger, correct, and other things also. And similarly, UMTS, WLAN, 2G and 3G, all sort of activities we are doing with the mobiles. And currently, all we are using the 4G services, correct. And these are the band, particularly 2.3 to 2.4 gigahertz we are using in India. And nowadays, you are also hearing about 5G is coming, and already the Jio has launched. So this is particularly within the band of 5 megahertz to 6 gigahertz. This is a very broad band, but particularly in India, we are going to use 3.2 to 4.2 gigahertz. In between that, we are going to use. Finally, we can see the ISM band. ISM is not Indian School of Mines. This is industrial, scientific, and medical applications. And these are the different bands actually. And one of the very great example I would present here. This is a microwave one in our kitchen, correct? So this is working at 2.45 gigahertz. Now, why this course? It is really very important, because the thing is, in the previous classes we interacted with the subjects with the low frequencies, and particularly we applied KVL and KCL, and we got the solution. Now the little bit there is a problem here. The problem is that we are going to deal with the lumped circuit representation, correct? And the thing is, we are not aware with this, because the thing is, like, here we don't have the capacitor, inductor, and resistor in our hand. Within the system, we need to decide which part will be acting as a capacitor, which part acting as a inductor at a particular frequency or particular electrical line. Correct? So these are the some of the challenges we need to sort it out, that how we will find it out these things so that we can make our circuit and it finally working for the particular applications. Right? So this is one sort of one sort of challenge actually I would say, and we'll try to see that how we can represent the lumped these things. Lumped circuit representation is no longer applies actually, and we need to find some other way. This is actually distributed elements, correct? So what is distributed element? Like in distributed elements, we cannot find the capacitor, inductor, and all sort of things, correct? What you did in your BTech first year lab, you have capacitor, you have inductor, you have resistor, and you are making over the breadboard, and in this way you are completing your circuit. But in particularly distributed approach, correct, we don't have this sort of freedom actually. We have a full circuit, correct, and these things, like this is based on the microstrip technology, and we need to find it out where the capacitor is, where the inductor is, and this is the challenge actually we need to come across, and we need to find the solution for these distributed systems. So finally I would say the lumped circuit representation is no longer applies here, correct? Now we need to think. So one of the example I can present here, like here we have an inductor at the low frequency. So particularly if you see this particular inductor, so you will see here that Z is equal to R plus J omega L. So this is the common thing. Like this particular coil will provide us the inductors at the low frequency. But how the things will be looking like that at high frequency, it is somewhat complicated actually. Correct? It is somewhat complicated. Now the thing is, because there is a high frequency involved here, so what will happen? There is a change of phase over the devices as well, and what will happen that between the two wires there is a high chance of getting the capacitance as well, and also we have the losses due to the dielectric as well here. Like here we have a ohmic losses which is represented by R. Here the losses due to the dielectric. Now the thing is, you will ask, should ask where is the dielectric actually? Now this is the media actually. Now right now here air is there, but there is a provision you can fill with the some dielectric material. Now in this case, can you find the Z? Can you find the Z, that what element would be deciding element for the impedance? Correct. Now let us understand here the cell phone transceiver circuit. So whatever we have seen, correct, in a close course curriculum, like we have seen the transmission line, we have seen the S parameter, and we have seen the active and passive domain. So all sort of knowledge actually we are going to apply in making the communication system. So this is a perfect example I would say. So here you can see this is a transistor circuit for mobile phone application, particularly 950 gigahertz and 1.9 gigahertz are the operating frequency. Mainly these are the GSM band, okay? And here you can see there are three different sections are there. Particularly this section, which is analog signal circuit, is our area where we have to do the things, we need to learn the things at the microwave frequencies. Now here you can see some sort of components like antenna, we have a power amplifier, we have a mixer, we have oscillator. Now this particular thing you see, so we already have the idea about the amplifier, mixers and oscillator. Now the thing is how we will make. The idea is that like in our previous courses we use the transistors, correct, capacitor, resistor and all sort of passive components utilized to make these circuits. Now here, as I told you, the system is distributed here, and this is really a challenging task, that how we can make these capacitor, inductor and all sort of basic components, and finally how to manage amplifiers at these high frequencies. So this is one of the challenge. Another thing is that you can see these are the arrows are there. This is like we need to make a physical connection, so we require a transmission line again. So to match with power amplifier with the antenna, this is a tedious task, because here you need to do some sort of matching and require the knowledge of the Smith chart. Similarly, the other parts also we need to do matching and other things. So the thing is we need to develop some sort of understanding to understand this part or this block actually, because we have to do here the transmission line, we have to do the matchings, we have to see the S parameter of different components, and finally we need to combine. Okay. And here you can see this is a digital to analog converter and analog to digital. You have the idea about. I'll not talk about much over this thing because here this is the part where we can be going to contribute and we are going to learn. Fine. Now the question is, okay, there this is fine. This is a block diagram, and we can develop the basic understanding from this block diagram. But after that, what? After that, how we will do the things? So here you can see this is the implementation part. So what we require the matching network, we require the BJT, FET, active devices, we require the biasing circuit. Fine. So these sort of exercise we need to perform. So these are the things we'll see in this course. And here you can see we arrange all the things in a different uh, in terms of the passive components, particularly lumped. This is a lumped model actually. Now it is not possible to do lumped model actually at this high frequency. So what we need to do? We need to get the idea about the printed circuit board, okay? Microstrip realizations, and the surface mount technology. So finally, you will see here we have the sort of matching lines are here. We have a transistors are there. We have a by DC bias networks are there, and here you can see this is the metal running over a different part of the circuits actually. This is made of uh, with the microstrip realization. So this sort of things we will be getting the idea once we have the knowledge of the transmission and how we can perform, how we can do this thing, do these things for particular circuits, correct? So we'll see all sort of things that how the things are working at higher frequencies and how we will do the implementation part by using the concept we are going to learn in this course. Finally, I would say you will be having the idea about a whole system after having the content of this course, because the thing is like any type of RF circuit you take or any sort of passive or active elements you take, you're supposed to develop the idea about the matchings. You're supposed to develop the how you will realize with the microstrip technology, and how you will find how we are going to just do those devices by the help of the S parameters. So these sort of exercise we will be performing. We start from the very basic and we'll touch very advanced level. Then we'll also see some subsystem level things also. And finally, I hope that you will be in that position after this course that you can understand the basic RF infrastructure. Correct. So definitely it will be helpful at the last. So hopefully the things will be fruitful in coming lectures. So thank you to all. Correct. If you have any question, we can discuss. Thanks.